Howdy. So today on the bench we have a Heathkit model IT-28. This is a capacitance checker, inductance checker. It'll check your voltage breakdown. It's also got the magic eye. These are pretty cool. I've already got the back off. It's 2 screws. She's in good shape. I forget how much I paid for this. I was told it does not power on. So before I plug it in, I'm going to just do some poking around because I don't want to blow any of those tubes. But the front, man, it looks great. The text is still pretty clear. Knobs are in good shape. This terminal looks a little bent. Took a hit maybe in. And these almost certainly need to be cleaned, along with all the knobs. I'll DeoxIT those. There's a great video that I watched. There's a few, if you look up Heathkit Indigo Tango-28 on YouTube, but I watched Def Palms. It was put up about 6 months ago. It's 2 parts, but really informative. He did a good job on this, and I learned quite a bit. So I will link that below because you'll probably learn more from him than me, but I learned a lot from him. So yeah, she's in good shape. I already blew it out. There was some cobwebs in there, but and, you know, tubes are a bit dusty. But other than that, looks okay. I was curious on these old caps, these 2 electrolytic caps, how much current we got on there. Excuse me, voltage. And let's just take a look here. I'm guessing not much. Oh, about 400 volts, microvolts, millivolts, geez. 4/100ths of a volt, let's say that. And this one, about the same. I wonder if my capacitor discharge wand will work with these, if it'll stay clipped. Maybe should have made that longer. Let's just see if that's a standing voltage or what. Now we've got 0 volts. So yeah, it does work. How about that? You know, I never made a video on this thing. It's just a long piece of brass, heat shrink all over, and I've got I think a 10K resistor in here. It's all taped up with a ground clip that can be changed. So in case this gets chewed up, you can change that. Pretty simple device, one-handed. Something I wanted to do that Mr. Def Palm did, because I'm curious how filthy. I'll put these screws here before I lose them. How filthy these terminals are. His were really dirty. He was having trouble with the connection, so I'm guessing mine are as well. Let's just take a look. Yeah. Hey, there we go. It's alive. Oh, my shoot. My Q-tips are just too big. That's a shame. So I bought Fashion Beauty. Oh, excuse me, Fenshine Beauty. In any case, they're smaller. Much smaller. Maybe too small. Well, they'll work. Let's see what happens here. That's to get into these terminals. Let's get some ISO going here. See what we get. Oh yeah, look at that, filthy. Right there, there's the wiper. There's a wiper there, and there's one down there. So let's see if I can come in at the right angle here. Not go too crazy. I'll get this one with my hand in the way. Yeah, already a little bit too much. Stay with me. Okay. And one right here. Oh, one down here, a fat one. Get some light on that. See if we got any excess here. Not too bad. On these, you can use a spray. That's kind of what the point of the spray is, to get in there with the straw. So, let's give it a shot. You can see it moving right there. Soak up some of that. Work that pretty good. Nice and smooth. On that one I did this, I did this. We did the terminals. I think that's pretty good. I already blew it out with some compressed air. So there's a little bit of dust in there still, and you can see the tubes are a little bit dusty, but that's fine. I'm not going to take those out unless I have to, unless I figure out they're bad. But yeah, so that's a good start. Okay, so I changed out a bunch of components. You got caps, a bunch of these fat resistors. I didn't change out all the parts that I ordered on the range dial. I did not go nuts there. They're kind of hard to get to, so we'll see how it behaves. But I have this connected to my ISO dim. I'm on limit, and I can turn external power on. And first time. Here we go. I'm drawing about 0.2 amps. No smoke. You can see my bulb. Well, you can kind of see. There's a little lit up there. So I think I pulled the maximum I can. But she's not shining too bright, so we're good there. I just don't think that's enough current. So we've got this tube's glowing. You can see that there. But I think the limit is what's preventing it from going all the way. So let's go bypass. Yeah, she's glowing nice and warm. Hey, look at that. You can kind of see it. Let me turn this off. How about that? We've got a green tube. Try to get this. There we go. Okay, so there's a bunch of checks here, of course. One, they tell you to use your finger. For real. I'm like, what? No, thank you. I don't think I will. I think the first thing is I'm going to check these voltages. See my multimeter there. So if I go to leakage, I should get 3 volts, right? And I've got nothing. Nope, nothing. Position to the electrolytic, yeah. So I've got no output here. I need these voltages. I should be getting 150, 200, 250, 300, 350, 400, 450, 500, 600. Well, that's not great. 600 is way higher. I've got 620 there. And just on the other side of it, I've got nothing. I'm on there. I can feel it. I took out that 22K resistor. Here she is. And yeah, if I hook this up to my meter, well, first let's check my meter here. What, 2.6. Let's go to continuous. If I connect this up, I gotta use clips because I got almost no leads on this thing. She is wide open. Nothing. Mega ohmage. So there's that. That would be a problem. Also, a bunch of these 10Ks. There's like 9 10Ks on here, all the way around. A couple were at 15K, 13K, 12K. So I just went nuts, and for better or worse, and changed them all. Oh, whoa, stay with me. Earthquake. Okay. There we go. Oh, this is hard to do. Okay. So, it's not too pretty. I was trying to match them. It's a really nice style. Every single one of those, they've got these tabs, and every single resistor was hooked. So 2 hooks on each. Of course, they're soldered, so that was kind of a pain. But I was able to get them all out. I've got a bunch of them here on the desk, and I'm pretty sure I got every single one. And they're all isolated. Nothing's touching what it shouldn't. No grounds. Leads are clipped. 22K is way buried in the back here, which was, these back ones were really tough. But anyway, let's hope that does it. So let's hope we get some voltage here. So let's turn this bad boy around. Oh, there's one stuck under there. Okay. I'm going to turn on my variac. Let me just double check it here. I guess I could turn off my soldering iron. 119, we're going to go down to 115 before I plug this in. 115, power's off. That's good. Discharge, plug this in. There we go. Power on. We'll give her a moment to warm up. Might as well change these leads out while I can. While I have a moment. I'm also gonna put these in. Go to volts DC. She's warming up. Maybe I turn this off. Yeah, it's a little better. So you can see it close when I go to bridge. Open, close. Maybe I can get a little closer here. So we want a leakage check. Let's go to the lowest setting. Let's go to ground. And haha! Of course you can't see that. It would help if you could. Get some of this crap out of the way here. So, supposed to be 3 volts. 2.75. Let's go around the horn here. 6 is 5.5. A little low. 10 volts is 10.3. 15 volts, 15.1. 25, 26.78. 50, 49.66. 100 is 101.8. 150 is 150.6. These are pretty good. 200 is 199. 250, 248. 300, 297. 350, 345. 400, 394. 450, 442-ish. 500, 491. A little low. 1%. 600 volts. 600. Oh, on the dot. Have mercy. How about that? I don't think this does anything. This either. It shouldn't. Well, that makes me feel great. How about that? You change
15 resistors. And things start to work. Imagine that. So that's pretty cool. We'll step it back down. We'll go down to, I don't know, 50. Nice. 15. 3. 2.7. That will do. 6. 10. Man, that's great. So that's a good start. Or middle. What's next? Let's see. Voltage tests. Now turn voltage to 16 positions. I did that. Voltmeter should be essentially the same. Voltage switch reading should be essentially the same as the voltage switch indications. And they were. You know, maybe a volt or two off, but they were pretty good. So next is bridge calibration and leakage calibration. Okay, so I bought a decade box. This unit off Amazon. Tested it out. Seems pretty accurate. All the way down to the ones place. That's a little less accurate, a couple ohms off, but pretty solid. I think it was 30 bucks. Not too bad. And I bought this meter here. I was going to get a nice fancy bench top, but I'm going to wait on that. But this has some good resolution way down to the microamps. So I have this set, just a loop through the decade box, through this in series, and then back. And we're going to try this procedure out. 2. And now, adjust the eye tube to just closed with the top calibrate control. So, of course, it's way over there. I am going to turn this light on. We're going to lose some brightness on that, but I need to see back here. And I need a screwing driver, which I probably should have got ready beforehand. This tweaker should work. I'm trying not to touch anything. Oh, okay. So, just closed. That's pretty close. Ah, yeah, she's sensitive. Let's just open. That's just a pinch. Just open. Just closed. Okay. 15.1. 15. Let that sit just a second. Okay, now 15 microamps. Adjust the bottom calibrate control to just closed. Where was I? So that was the top. Let's see if you can find the bottom here. There's open. Just closed. Up. Just open. Just closed. Okay, finally, set the control as paper. Leakage. If necessary, reduce the voltage switch setting. I mean, sure. And now we want 2 microamps. So I'll go down to 6. Two microamps. Let's go up to 2 micro. Okay. Now adjust the middle center. Okay. Let's try that. There's open and just closed. Ooh, that one's a little easier to do. It kind of, wow, it's got its own action. So you start it and then it takes over. Like I'm not turning the whole time. If I just start tweaking this, it kind of closes on its own right there. Yeah, I'm only barely touching that, and it's got momentum, I guess, or inertia. My physics teacher would have a word. There we go. That's basically it. Oh, just a bit. There we go. 2 micro closed. Okay. So now, let's go to discharge. Should lose our current. Okay, good. Turn this off. Now let's test something. Yeah, I'll set up the test. Okay, we'll try to test out this resistance measurement here. So, resistance measurement. Connect the unknown resistance. We'll pretend like we don't know what this is. To terminal, set the range switch to one of the R multipliers. I'm on ×1. Gen switch should always be in the internal position unless using external, which I'm not. The type, voltage, and power factor controls are not used in this test. Okay. Set the bridge leakage switch to bridge. Adjust the balance control for maximum I tube opening. So let's see if I can find my standard here. R, it's the middle here, and this is 1,000 ohms. So I want to be right around there. This thing should open up, right? Ha! How about that? So maximum is right about there. That's pretty close. That is pretty close. I'm about, I don't know, 2 or 3 millimeters off of 1,000. I don't know if you can see that. So 1K right there. That's pretty much dead nuts on 1K. And it's still open, just a little not as open. That's it right there. That's pretty good. Let's try 2K. That should close, and then I should move up here. It should open again. Yeah, there we go. There's 2K. That's dead on. Nice. Okay. Let's try a multiplier. Let's go 0. And we'll go, I don't know if it goes this high. Oops. 100K. And this will be 10K. Actually, we'll go 10K. And we'll go 100 times, where are we? What? Oh, I don't have that. Okay. 50. Nope. Now I'm reading my own thing wrong here. Is this open anywhere? Yeah, there we go. There we go. 50. Yeah. So 500 times 100 is 50K. That's pretty close. And then if I go, let's say 10K. Actually, this should be. So 10K. Oh, I should be back down here by 1 then, right? I keep looking at the wrong scale. That's one thing. A lot of numbers going on here. And it's easy for your eye to stay with me. It's very easy for your eye to look at the wrong scale. I want the second in. Okay. So I'm on 100K, which is 10K times 10, but it's not opening. Oh, there we go. So that doesn't seem correct, is it? Oh yeah, second one in. Sorry. Again, I was looking at, geez, by the time you make it around here in my eyes, I jump a rail. So 10 is way up there in the top. Not the first one, but the second one. So 10. Just a little off, but pretty close. 10 times 10K, you get your 100K right here. So that's pretty cool. So resistance measurements. I know this seems you know, antiquated now in the time of a DMM. Why would you ever use one of these? Well, in 1968, this is what you would use. So that's pretty cool. Also, it just looks a lot cooler. You got the magic eye, baby. Let me see if I can figure out a capacitance measurement. Okay, I was able to scrounge up a 1 micro electrolytic, which is right kind of in the middle of that range. Let's make sure here. Yeah, right in the middle. And so I'm on discharge. We'll go to bridge. Eye closes. Electrolytic times 1. I want this second inner. So I should open right around here-ish on that 1. If I turn it, it does start to open. That's as wide as point right there. And that's pretty close. We can get a good angle on that. There we go. That's almost directly 1. Now, something I noticed, this power factor matters a lot. If I even breathe on this thing, it actually opens up a little bit more off 0. But this whole time I had this cranked over, I wasn't paying much attention to it, and I think it was on 45 or 35, but I think that might have had something to do with my measurements not acting the way I thought they should. But if I go 0, that's pretty accurate. That's 1 for 1 micro. So that's cool. We'll do a 3 pico. This is a ceramic. It does not want to focus, but you'll have to trust me on that. So polarity is not a concern. 3 pico. We'll go down to paper mica, bridge. So I'm going to have to go way down, I believe. Yep, there we go. Look at that. 0.3. So the scale is point. This says divide. This still kind of confuses me. It's hooked to this. I think that's for the external, to be honest. I'm sure someone knows better than I what that means exactly or how to work that. But 0.0001 and 0.3 micro. Multiply that out. That's pico. It's minus 12. So that's pretty close. That's 0.3. I'm looking at this scale right here now. The second one in. That's fully open-ish. That's pretty close. Not too shabby. Let's see if this matters. So now the power factor doesn't matter at all here, so I don't know. That's strange. For the electrolytic, it seemed to. For this one, not one bit. Also, the voltage should not matter at all. Huh. Anyway, that's kind of cool. So that's 2 that measured right. Ish. We'll take it. So another feature of this unit is the external standard terminals. These allow you to hook up a resistor, a capacitor, or an inductor as a standard, a known value here, and then you connect an unknown value to the test leads, the test inputs down here. You can also use this along with these terminals to determine the turns ratio on a transformer, which is pretty cool. But I'm going to try this. So I've got a 10K here, and I've got a 10K here. And now we're looking at the very outer scale here. That's external standard. Let me zoom in here. You can see right there, external standard. So this should be, if I go to bridge, this should open up when I'm roughly about at 1, which is dead center on the bottom there. So if I go down here, oh, it also helps if I'm in external standard. There we go. There we go. So yeah, just about 1 to 1. That's pretty cool. So now let's try it with one more, just for fun. This is a 47K. Again, I got a 10K on the standard. So on, you can see on the scale here, if your pointer is on this side, you multiply for resistance. If your pointer is on this side, you divide. So we should be over here. So let's go to bridge. She closes. And when I move this over, without my hand in the way, when I get to about 4.7, it should open up. Ah, there we go. Pretty close. Let's see if we can see what we're at there. 5, 4, 4.5. That's pretty good. So basically, what this is saying is 10K is my standard, times 4.7 is 47K on the test leads. So pretty cool. What a cool feature. I like that a lot. So that's going to do it for this video. This was a success. They don't always go that way. If you watch my videos, you've seen that. But this one went well. Changed out 3 paper caps, the filter caps on the AC in, probably a dozen or so resistors. One was wide open. A lot of them were out of tolerance. The eye looks great. It's responsive, nice and bright. Maybe you can't tell on screen with the lights, overhead light on, but it is pretty bright. It looks really clear. We checked the leakage. We checked the bridge functionality. Measured some capacitors, resistors. We checked the external standard. That worked well. Was able to determine an unknown resistance value, so that's cool. Yeah, very pleased with this. Not sure what I'm going to do with it. Maybe stick it on the bench. I could sell it. They go for a pretty penny on eBay. I'm not particularly concerned about making money on it. I'm just glad it works. I'm glad I bought it, and I'm glad I fixed it. And I'm glad you guys watched this video, so thank you for that. I appreciate it. Like and subscribe if you'd like. And yeah, I'll see you in the next one.